Welcome to the Rich Report, a podcast with news and information on high performance computing. Today, my guest is from SGI. We have Tony DeVarco. He is the Director of Virtual Product Design Manufacturing Solutions at the company. Tony, how are you doing this morning?
Doing quite well, Rich. I appreciate this opportunity.
Yeah, it's great we could get together before SC16, but I wanted to learn more about what SGI's been up to with, making it easier for these small and medium kind of manufacturers to adopt HPC.
Well, that's something that we've been focusing on for several years now, and I definitely look forward to sharing that with you.
Well, can you tell us a little bit about your role? Certainly, you're working on more than just talking to us radio folks during the day. What's going on with you at SGI? What's your mission?
So I manage a vertical within SGI. It's manufacturing at a high level, but then we go down to the next level and CAE, computer-aided engineering type of workflows, as well as EDA type workflows. And I set strategy. I work with our software partners like ANSYS or LSTC or Altair. And I work with our sales reps to talk to our customers about what their needs are. We try to build our solutions around what our customers value most, which is really running their applications efficiently.
Well, with that, Tony, I brought your slides up. Why don't we go through those and then we'll do a Q&A at the end.
Sure, that sounds great. So we'll just start off. This is titled Meeting Manufacturing's Needs for Production Supercomputing. And I think, supercomputing, a lot of times people think, oh my gosh, it's, very complicated. There's the whole idea of ease of use and such. And in fact, talking to my colleagues at ANSYS, I've been told, around 50% of their customers still just use workstations. So they're interested in moving people into using high performance computing. And so with SGI, we really focus on what we call production supercomputing. So this is allowing manufacturers to get the most out of the simulation applications that they are buying. And what we want to do is build and deliver and support complete solutions for our customers. And that may be for computational fluid dynamics, or maybe for electromagnetics, or as you see in the low right-hand corner, crash simulation. So there's some challenges that we've talked with manufacturing customers, and these four seem to be universal everywhere in the world as I talk to customers. The first one is increasing engineering productivity. We want to, engineers, their time is limited. They're very highly needed assets for delivering product, and they have to be fed information and their ability to do their work very quickly. There's also the management are trying to speed up production development time, so you bring your product to market more quickly, and simulation is a way that customers do that. The third one is reducing physical prototyping to save both time and cost. So if we go back to that crash simulation, everybody knows if you had to do physical prototypes and crash a car, do the testing, the physical testing, redesign, create another physical prototype, not only does that take a lot of time, but it's very, very expensive. So over the past 10 to 15 years, the simulation software and the whole industry has come together to help with virtual prototyping and to take the time of physical prototyping and the costs down. And then finally, really, it's the inefficient use of expensive ISV licenses. Years ago, it used to be, the hardware was 5 times more expensive than the software. And really, we're finding that that's now flipped. And so as a hardware provider, if we can help with your workflow and allow you to run these software licenses 7/24, get the most out of it, that's a great benefit. The other area that we're hearing from our customers is something that remote visualization is addressing. And they have, a lot of folks have development groups different parts of geography. It could be in EMEA, or it could be in Japan and the United States. These are groups that are having to work together on a particular project. And these distributed workstations that they're doing can't really interact with each other. And there's also this other dynamic of these are very expensive workstations, and they're looking, IT and upper management are looking to consolidate the ability to share data within a data center and to replace very expensive workstations with low-cost remote clients. So these are sort of the dynamics that I see universally around the globe. Now, what we try to do is we build our solution around the physical domains that I mentioned earlier: computational structural mechanics, both implicit and explicit, computational fluid dynamics, computational electromagnetics. There's always pre and post processing that has to happen. And then there's data management, simulation data management. And in that gray bar, you see some of the applications that I manage. And we also have folks that are in our apps engineering group that also, on the technical side, have relationships with these various vendors. And we typically do benchmarks with our customers to help size their problem and to size the system that they're looking to buy. And really, the process is we provide both scale up, which is shared memory systems, and scale out, distributed computing systems. And all our systems have a Linux OS. We have our own management center for the health and the bring up of the system. And we also have our what we call SGI Performance Suite, which has MPT, which is our message passing toolkit. We work with ISVs. There are certain executables that are native to our MPI, but we also have a software shim called PerfBoost that allows other MPI implementations to use. We use then our MPI in our systems to get a little bit more of a performance boost. The next is a workload scheduling tool. We work with most of the modern scheduling tools. PBS is our preferred. And then on top of that is the SGI Viz Server solution, which is helping with remote graphics, which I mentioned earlier. And all of this is then brought together with our services. And we try to do a whole end-to-end services where if you need remote sysadmin, we can help. Obviously, installation of the cluster, all the things that get you up and running. We build and test the cluster in our factory. We could install the software if you want. So all of that is worked through in the pre-sales process. Now, I wanted to focus a little bit on CFD because at SC16 in our booth, we're going to really highlight computational fluid dynamics. And earlier actually in September, we announced with ANSYS a new scaling world record of 145,152 cores. This basically was a great example of using a balanced production supercomputer to really scale something that ANSYS Fluent that hadn't scaled. I think it was 129,000 was the previous world record. And what was great about this was we had a large system on our factory floor. There's a group called NCAR that does weather modeling and research. And we had that on our shop floor, and we were able to take advantage of it and run this application on a ICE-XA system, which you see a picture of it there. And so this shows the linear scalability of it, the scaling of it. The red is linear, and the blue shows the efficiency rating from about 1,000 cores up to the 145,000 plus cores. And the interesting thing about this is the cell model was 830 million cells. It's a gas combustor model that was provided to us by ANSYS. And with 1,296 cores, that model took 20 minutes to run. But when we ran that same model on the 145,000 cores, it finished in 13 seconds. So it really was a great reduction in time. And I also wanted to share an industry example that highlights the advantage of CFD using our SGI UV system, which is a shared memory system. And we've been doing shared memory systems for many years now. Here's a picture showing from 1996 to 2015, starting out with the Origin 2000, which was a MIPS processor IRIX-based system, the Origin 3000 as well. And then in 2003, we brought out the Itanium systems, and in 2010, x86 Intel systems, and the name was the SGI UV. And now we have both SGI UV 3000 as well as a smaller 4-socket system that scales called the SGI UV 300. Now, what's great about this UV system is if you're a small group, you can do all your workflow on one system. So you can do your pre-processing, your mesh generation, decompose your model, run your solvers, do your post-processing and your visualization and storage, all in one sort of large, what we call a large workstation. So if you don't have a lot of experience in managing a cluster, and you're a small work group, this is something that our customers see value in. And one of those customers was a gentleman named Mark Taylor. And we met Mark many years ago when he was head of CFD at McLaren F1. And he has started his own company called London Computational Solutions. And he is working with a group called Elemental Cars, which is an advanced track car manufacturer. They had their first car, it's called the R1, came out earlier this summer. And in fact, Mark will be in our booth at SC16. He's going to be doing some CFD demos on a UV system. And we're going to have one of these cars in our booth. So you'll be able to see this great Elemental Cars at our booth. So I encourage people to come. So the goal of what Elemental came to Mark was they wanted to improve their cornering speed. And in order to do that, you had to look at the undercarriage and really work on the vertical force so that the tires would grip the road more properly. And so what Mark said to us was, when he was the principal aerodynamist at McLaren, that he really relied on the UV system because of its robustness, reliability, and efficiency. And then when he was asked at LCS by Elemental to work on this project, which had a quick turnaround, he knew if he used a UV system, he would be able to quickly turn the project around because the software just works on the UV system. So this was a really great benefit for him. And in this next slide, I wanted to show on the left side, this is a top view animation of London Computational Solutions software. And then on the right side, I wanted to show you the undercarriage and how the undercarriage was designed using CFD to create more downforce and to create better grip for the tires. So those are a few areas within CFD I wanted to share with you, Rich, and your audience. So we can go to some questions if you like.
Oh, great. Well, Tony, I want to start out with that big example for Fluent. If you could go back to that quickly. Scaling Fluent to over 145,000 cores. I mean, till recently, there weren't even more than a handful of machines in the whole world that had that many cores.
Yeah.
When you talk to the customers out there, does this kind of case study kind of, light up the possibilities for them?
Yeah, absolutely, Rich. We actually have a major automotive customer who currently has 2 full-scale wind tunnels in operation and is planning to build one more in 2019 at a cost of around $100 million. And they've told us that they estimate that they could save around $22.5 million a year by using CFD and really to reduce the expensive aero parts and really do body shape optimization to actually reduce that cost. And it's obvious that the use of wind tunnels is very costly and to not only build and maintain. And they told us their goal is by 2040 to use CFD simulations exclusively and stop having to rely on costly wind tunnels. And of course, they want us obviously still make cars that are better and safer, but they believe they have a roadmap to just use CFD in by 2040.
And the other example you cited about the car, that you're trying to get it to grip the road better, was it the large memory that made that efficient for that customer? So it didn't have to page out to disk to fit everything into the system?
That was definitely one of the benefits. It was
Yeah.
also a very large many cell model.
Hmm.
And what we were told, they do like a fifth order of CFD. It's a much more finer grain CFD calculation, and Mark really didn't want to have a hassle of trying to break up the problem to fit on a cluster, and so just putting it on a large shared memory was the way he knew he was going to get the job done and get the results back to his customer in the short time frame they asked.
And Tony, you showed the diagram of all the pieces that SGI puts together. There has to be a lot of complex technology orchestration going on, right? I mean, uh, do the lessons you learn from these exercises like the Fluent big problem, does that transfer to other applications?
Yes, it does. And in fact, what we found is so Fluent does not have an executable that uses SGI's MPI, and so we did use PerfBoost, which is what I mentioned earlier. And when we were scaling it, we scaled it in chunks, and we didn't try to just run the first time at 145,000 cores. That would have been probably insane. But we, started out at 1,000 cores and then incrementally went up. And when we got to, I think it was 40,000 cores, we actually found a bug in our MPI that typically we wouldn't have found if we didn't do this because
Right.
we don't necessarily have these large systems. So we were able to fix that bug,
Yeah.
which actually will help anybody who has a large system using our MPI beyond 40,000 cores.
Yeah.
So
Yeah.
just on that it was well worth it.
Sure. Sure. Well, Tony, you've gone over some great examples here of what you guys are calling production supercomputing. It is what it says it is. You're making it practical at SGI. How does this message kind of resonate with your customers out there?
Well, so we really want to work with customers, as you said, the small to medium customers. We take the expertise we get from our large customers so that there's not a lot of guesswork when we're talking to our small customers.
Hmm.
It really helps in the conversation. We know their applications. We're able to profile them through benchmarking if that's what they need. And we really want to be their trusted advisors throughout the whole process. And I've gotten feedback from our customers that, typically when they talk to other hardware providers, all they're saying is, here's our speeds, our feeds, that's it. And we're actually talking about, oh, here's your application. This is how many times you can run it at this size model. This is how you can invest, move the data from here to there. All the things that they need for their workflow, they value that SGI and our sales, our engineering, our services group brings to the table.
Well, great, Tony. I know we're coming up here on SC16, and you mentioned that you'll be showing some of this work at the show. Where can they find you at SC16 coming up in Salt Lake?
So they can email me at tdevarco@sgi.com, and we can set up a meeting. I'll be in our booth probably at least 3 or 4 hours a day.
Hmm.
Um, and Mark Taylor will be there as well. There will be probably a listing of when he'll be there. He is going to be part of the SGI Innovators Breakfast. He'll be doing a talk there. So I encourage people to come to our booth and see what we're doing.
Okay, Tony. Well, hey, this has been really interesting, and I want to thank you once again for coming on the show today.
Thanks, Rich. It was great.
Okay, that's it for the Rich Report, folks. We'll see you next time with more news and information on high performance computing.